Welcome to my channel, everybody, and this is the chapter about the indeterminate form. When a limit like when the put the values tends to 0, then we get 0 by 0 and also infinity by infinity, and that type of a form is called the indeterminate form, like limit x tends to a, and that is the f of x, and this is the phi of x. If we put a and this is a, when f of a is equal to phi of a equal to 0, or f of a and phi of a equal to infinity, then we can apply the rules indeterminate form. When this called the indeterminate form, 0 by 0 or infinity by infinity, then we can say that this form is called the indeterminate form. So we apply the rules is that differentiate on the numerator part and also differentiate on the denominator part. Again f of f dash a is equal to phi dash a equal to 0, or f dash a equal to phi dash a equal to infinity, then we can apply again the differentiate like that, f double dash. Okay, and then proceed this manner. Okay, so this is called the indeterminate form. Now some problem we have to solve this. For question number 1, see, limit here is x tends to 0, e to the power x, e to the power minus x, 2x whole divided by x minus sin x. See, if we put 0 on this, then we get 0 by 0 form. So we apply the lhospitals rule. So apply the okay. So what is the rules? Then differentiate. We get here e to the power x plus e to the power minus x minus 2, 1 minus cos x. Again, if we put x tends to 0, again 0 by 0 form. So again apply the lhospitals rules. So rules is that differentiate on the numerator part. This is 0 here, and this is, we get this. If we divide it by x also, then you get the standard value, and then we can also differentiate. Okay, again we can say this is 0 by 0 form. So apply the lhospitals rules is that e to the power x plus e to the power minus x, and this is cos x. Now put the value of 0. This is 1 plus 1 by 1, this is 2. This is your answer. So this is called the indeterminate form. So apply the lhospitals rules, and this is the procedure. Okay. So now proceed to the second question. See, here is limit x tends to pi by 2. This is your 1 minus sin x to the power, no, this is into tan x. So we need to convert in the form of, in the pattern of 0 by 0 and infinity by infinity. Then after we differentiate. But this is an into form, so we can't get that form. So first of all we can arrange this like tan. We can write here cot. Then if we put here pi by 2, cot pi by 2 is here 0. And if we put here 90, then sin 90 means 1 minus 1 0. So this is 0 by 0 form. Okay, so apply the lhospitals rules. So need to the pattern. We always convert in the form of 0 by 0 or infinity by infinity. Then we can apply the lhospital rules. Yeah, lhospital rules. And differentiate this, then we get here minus cos square x. And first you simplify, then put the value. So see here, if we put pi by 2, we get the exactly value. And that is here minus, this is plus, and 0 by this is here 1. So it is 0. Now third is that the limit in my some video, I am saying always if the function be variable to the variable for differentiate or something and taking log on both sides. Okay, so let us assume this is a and this is cos x and to the power cot square x. Take a log to the base, we get cot square x and log cos x, and this is your log cos x by tan square x. Therefore limit x tends to 0, log cos x by tan square x, and this is equal to, so see if we put there 0, then log 1 is 0 and tan 0 is 0, so this is called the 0 by 0 form. 0 by 0 form. So apply the lhospitals rule. Differentiate, this is 1 by cos and this is sin x. This is here 2 tan x and this is sec square x. That is minus limit x tends to 0 tan x. This is here 2 tan x and sec square x. X tends to 0, x never be 0. Then after limit x tends to 0, 1 by 2 cos square. This is half. Okay, so this is your answer. Okay. No. This is not answer. This is a logarithm of that. So this is limit x tends to 0 and log a to the base e head. Okay. So therefore the log to the base e, limit x tends to 0, a value is half. So therefore we can take anti-log. Then x tends to 0, a, and it will be to the power minus half. Okay, this is your answer. A means this is your figure. Okay. So now proceed to the fourth question. This is your fourth, means limit x tends to 0, x minus sin x by x cube. See, this is 0 by 0 form. We can apply the lhospital rules. Need to write here, we apply the lhospital rules. This is the indeterminate form, so we can apply the lhospital rules. Okay, and this is your cos x, this is 3x square. Again this is a 0 by 0 form. So see, put there 0, 1 minus 1 0, and this is 0, this is 0. So again we apply the differentiate, this is minus plus sin x, and this is a 6x. Like the standard form is also sin x by x is equal here 1, and we can write here 1 by 6 into 1, that is 1 by 6, but you can also can show that differentiate, if you put 0 by 0, this is 0 by 0 form, so cos x, and this is here 1, so we can write here cos 0 also, this is 1 by 6 here, okay. So this is the question number 4, okay. And now here is question, find a and the limit. Find a, okay, and also find the limit. Okay, and this is 5 here. Important question. This is x tends to 0. Sin 2x plus a sin x by x. See, this is a 0 by 0 form. Apply the indeterminate form. This is the indeterminate form. We apply the lhospitals rules. So that's why we differentiate. We get here 3x square, and this is here 2 cos twice x, and this is a cos x. Since it has a finite value, actually need to given, and the condition B is a finite value, okay. So as here x tends to 0, then 3x square is also tends to 0, then 2 cos 2x means 0, a cos 0, and this is equal to need to 0. As the denominator part be 0, so also numerator part be 0, then we get a finite value, okay. So we can write that, that's why, okay. So 2 plus a equal to 0, so we get here minus 2, this is the answer. And find the limit here. So then again, this is the answer, one question, and limit is here, limit x tends to 0. This is 2 cos twice x, and the value of x is minus 2, and this is here 3x square. Now limit x tends to 0, take account to cos c minus cos d, and also you can differentiate also if we get 0 by 0 form. So this is 2 sin twice x plus this is sin x by okay, this is 6x. Again this is 0 by 0 form, so apply the lhospitals rules, and 2 by 6 here, limit x tends to 0, differentiate this is 4 cos twice x, this is cos x by x is 1 here. So now this is here minus 4 plus 1, this is here minus 1, okay, this is here minus 1. So value is here minus 1, and the limit of a is here minus 2. Okay, see the calculation carefully. And now proceed to the question number 6. Limit x tends to 0, tan x by x to the power 1 by x. Again, this is variable to the variable, so we take a, and this is 1 by x. So log r to the power z, this is 1 by x, log tan x by x. So take a limit on both sides. by x. If x tends to 0, tan x by x is 1. So log 1 is 0. Again this is 0. So 0 by 0 form. So yeah, apply the lhospitals rule directly. So differentiate log x. So that is we get here 1 by x. Okay. And differentiate like u by v here. Okay. X square x into sec square x. Okay. And tan x dx of x is 1. And this is here 1. Limit x tends to 0. X tan x sec square x minus tan x. This is 0 by 0 again. Okay, so apply the lhospital rule. Limit x tends to 0. Sorry, x 2 sec x, and derivative of sec x is sec x tan x. Okay, again last sec square x, dx of x is 1. Differentiate tan x is sec square x sec square x, and tan x is 1. So these two are cancelled. So limit x tends to 0. So 2x sec square x tan x sec square x and tan x. Now see, divided by x on both sides. Sorry, not both sides. Numerator part and denominator part by x. Then we get here 2 sec square x only tan x. Here is sec square x. Then we get the tan x by x here. So now see, this is 2 into sec 0 into tan 0 by this is here 1 plus 1. So this is a 0. So again check it, x tan x, okay, x square, x into 2 sec x, and derivative of sec x tan x, and sec square x is 1, and derivative of tan x is sec square x sec square x and tan x, okay. Then sec square x cancel, and now 2 sec square x tan x divided by x on numerator and denominator part. Then we get on the denominator part b there 2 and numerator part b 0, so it's 0. So this is 0 here, okay. And now this is the logarithm of that, so we can write again. So limit x tends to 0 log a, so we write here a and log of to the base is that, and this is here 0 means log to the base 1 here. So this is limit x tends to 0 a, and that is equal to 1. Okay. And now next question, you have to proceed. That's 7. Actually 7 not needed to solve, and that is equivalent to this is 4. Multiply by 2 on numerator divided by this is twice x and sin twice x, and same problem is this, okay. So this is like 4, so not needed to do the problem here. Now question number 8 here, see, this is 8. Limit x tends to 0. So this is integral 0 to x e to the power x square dx whole square, and divided by 0 to x e to the power 2x square dx. So this is also called 0 by 0 form. So differentiate the numerator and denominator part. So this is 0 by 0. Sorry, this is infinity by infinity. Okay, so this is infinity by infinity form. So you apply the L'Hospital rules. Rules is that differentiate. This is 2 and within the bracket 2 integral 0 to x e to the power x square and dx. Again differentiate 0 to x e to the power x square and dx here. Okay, and differentiate this, then we get e to the power upper limit. Okay, so this is your dx of 0 to x e to the power 2x square and dx. And now see the rules here. This is 2 into 0 to x e to the power x square dx. Okay, and rules is that put the upper limit. Okay, and differentiate ddx of x, and then put the lower limit. This is e to the power 0 and ddx of this is 0. This is the rules. Okay, same as on the divided part. This is e to the power twice x square, so ddx of x here, then after e to the power 0 again ddx of lower limit. This is the rules. Limit x tends to 0. Okay, sorry, this is given infinity, so that's why infinity. I wrongly written. Okay, these all are infinity. So see, this is 2 into integral 0 to x e to the power x square dx. Okay, and this is here e to the power x square only. Same as if you got twice x square only. Okay, these two part are cancelled, so you get here e to the power x square. So again, this is also infinity by infinity form. So apply the last rules is that again ddx of 0 to x e to the power x square, and this is dx, and ddx of e to the power x square. Okay, and same as x tends to infinity. Okay, so e to the power x square and ddx of x is 1. Another thing is that, so again differentiate e to the power x square, and e to the power x square is twice x. So these two are cancelled since x tends to infinity. Okay, then there is 2x. Okay, 2 are cancelled. This is 1 by infinity means 0, big number. Okay, this is the answer. See, this is the question number 8 here. And now see carefully. Okay, very interesting question. Okay, now we want to do the question number 10. After that we have proceed the question number 9. Okay, see, this is here 10. Let a equal to sin x by x and whole to the power 1 by x square. So taking logarithm on both sides, so log a to the power z, and this is equal to 1 by x square log of sin x by x. Okay, so therefore limit x tends to 0 log e to the power z, and this is limit x tends to 0 1 by x square and log of sin x by x. Since sin x by x is 1, so log 1 is 0 by 0, so this is 0 by 0 form. So apply the L'Hospital rules. Rule is that the differential of x square is twice x. Again differential of this is x by sin x, and differentiate this as a u by v, x square x cos x minus sin x. Okay, now simplify this as this is x are cancelled, so 2x square, x is x square sin x, and this is here x cos x minus sin x. Again see, this is 0 by 0 form. So apply the LHospital rules, that is x minus sin x, okay, x minus sin x and plus cos x, and x is 1 minus cos x. This is here 2 x square cos x twice x sin x. Okay, this sin cos x are cancelled. Now x tends to 0 here, so divided by x square on both sides. So x sin x by x square. So this is here 2 into divided by x square, 2 into divided by x square. Okay, so see, sin x by x, okay, sin x by x, this is minus 1, this is 2, this is here 1, this is 2, this is minus 1 by 6. So see, this is log 2 divided by e, limit x tends to 0, and this is here a. Therefore, limit x tends to 0, a, and that is equal to e to the power minus 1 by 6. And given that e to the power a, so this is b, given. Therefore, the value of b is equal to minus 1 by 6. Okay? See, this is a very interesting question. And now, last question is 9. This is 10. Now proceed to the last question is 9. Find ABC, and when x tends to 0, this is your limit x tends to 0, a e to the power x, b cos x, c e to the power minus x by x sin x. And given that this tends to 2, here 2. So since this is 0, as x tends to 0, then x sin x tends to 0. Therefore, a e to the power 0 minus b cos 0 plus c into the power minus 0 equal to also 0. If this 0 and this 0, then this is called 0 by 0. Then we have a finite value. Okay, and see, this is the finite value, given that the limit is 2 here. Okay, so we can write this is equal to 0 if this is 0. Okay, so that's why a minus b plus c equal to 0. So therefore b equal to a plus c. Put in place of b here. Okay, then x tends to 0 here. So a e to the power x, in place of b we can write here a plus c and cos x, and c e to the power minus x by x sin x. See, if we put there 0, then we get 0, and also put there 0, then we get 0. This is called 0 by 0 form. So apply the LHospital rule. Okay, limit x tends to 0. Okay, this is here a e to the power x minus minus plus a plus c, and sin x minus c e to the power minus x by x cos x plus sin x. Again, see, if we divide it by okay, there is some problem. I think if we, this is 0 0 0, okay, as again x tends to 0, then x cos x plus sin x equal to 0. Therefore, on the numerator part be also 0. A plus c into the power 0 equal to 0. Okay, so a equal to c. This is equal to 2. Okay. Then from 1, limit x tends to 0, a e to the power x. A equal to c, you can put here 2a. Okay, this is equal to is given. Now, so then we take a common a, that is a. Okay, so e to the power x, e to the power minus x, 2 sin x, and whole divided by x. Okay, x cos x plus sin x whole divided by x, and this is given that this is 2. So a into limit x tends to 0. This is e to the power x minus x. So you can write here e to the power x minus 1. So minus e to the power minus x minus 1. This is here by x. This is also by x. That is here 2 into, that is here e to the power x minus 1 by x, and this is here minus. So it is here minus, doing here plus, multiplied by minus, it is here minus x minus 1, okay, plus 2 sin x by x, okay, and actually this is was that for minus, so doing here minus and represent here minus as the power is here minus, and divided by x here, so we get here cos x plus sin x by x here, okay, and we can write easily 1 1 and this is 2, 1 1 2 by 2, okay, and equal to 2. So this is 4a by 2 equal to 2, therefore 4a equal to 4, so a equal to 1. So that actually a equal to c here, so a equal to c equal to 1, so the b is here a plus c, so that is 1 plus 1 and that is equal to 2, okay. Goodbye everybody.